So folks, we're going to look at factoring trinomials now, which is usually when people think about factoring, that's what they think about, is factoring trinomials. Remember, we defined that in the previous video. If you want a more general overview of factoring, go ahead and click this link to take you to the pre-work that came before this. So we want to look at factoring these trinomials. Because this is a somewhat challenging procedure, I'm going to start by making sure that all of our trinomials that I ask you to work with have prime, leading, and trailing coefficients. These will be the problems that we work in this section. But what's difficult then is if students learn a method that just works for these, they're not able to utilize that method when you have more difficult leading and trailing coefficients. So notice this has a leading coefficient of 3, whereas this has a leading coefficient of 12. And 3 is a prime number, but 12 is composite. It has lots of factored pairs. Likewise, this has a trailing coefficient of 5, whereas this has a trailing coefficient of 15, and this has more factored pairs. These are the problems that I want you to be comfortable with factoring, but to get us there, we're going to start a little bit easier. So typically what you're going to do for a problem like this is factor 12x squared plus 11x minus 15. What we'll do is we're first going to identify the leading coefficient, and we're going to identify the trailing coefficient. Usually, if this is a quadratic, the leading coefficient will be the coefficient in front of the x squared term, and the trailing coefficient will be the constant term. But this is a general method that works in a lot of instances. Okay, so what we're going to do then is we're going to make a table with our factored pairs of our leading coefficient and our trailing coefficient for the given trinomial. So the factored pairs I'm talking about, I'm not going to worry about the sign. For example, minus 6 and minus 2 multiply to give us 12. But I'd just like to take care of the factored pair 6 and 2. So I'm going to write out all of the factored pairs of the number 12, not worrying about the sign. So the first is 1 times 12. If I multiply those two numbers together, I get the number 12. Likewise, if I do 2 times 6, I get 12. And likewise, if I do 3 times 4. Similarly, over here, if I list out all the factored pairs of 15, I have 1 and 15, and I have 3 and 5. I want to point out a bookkeeping method that I'm using here. I'm starting with 1. 1 will always divide into any number, and then you'll multiply it by the number itself. And then notice that I'm systematically increasing this as I can for divisors of the number 12. I think that's a good bookkeeping strategy rather than just writing these pairs willy-nilly. You may have a hard time making sure you've identified all the factored pairs. Okay, so this is a more challenging problem than the ones we're going to work in this section, but this is the type of problem that I want you eventually able to work. So here we've listed our factor pairs of the leading coefficient and the trailing coefficient. All right, so moving down to here, we're going to do exactly just that. Here's our leading coefficient of 3, and here's our trailing coefficient of 5. And so if we write out the factor pairs of the leading and trailing coefficients, we have just 1 times 3 and 1 times 5. Now, in more difficult problems, you'll have many more factored pairs here. But in this problem, because both of these are prime, this is relatively straightforward. Okay, so we're setting this up, and we have that 3x squared minus 14x minus 5. We're going to try to factor this trinomial. And so let me make that just a little bit bigger here. Oops, just a little bit bigger. Here. And so all I'm going to really do is systematically try all possible numbers that can go in each of these 4 positions. I actually see 4 positions here. Let me go ahead and write that out. I've got 1, x, and I still didn't get the size right. Let's try that again. 1x, and then I'll have a sign there and a number. And then I'm going to have something x, and then there'll be a sign that eventually goes here, and then a number. So all I'm doing is I'm choosing which pairs of numbers I should put in for these blanks, and then I'll also have to decide upon the signs. And all I do in this method is I systematically check all possible combinations. And you can see that in long problems, that can be difficult. So what I'd like to do is this time, first time through, is I'm going to just kind of mimic what we have going on here. If I have 1x and 3x for these, if I put a 1 here and a 3 here, notice that when I FOIL this out, this will give me a 3x squared. Likewise, and here I'm going to let's make sure we do it wrong the first time, Charles. So likewise, I'm going to put this Now let me see here. We've got two ones in this problem, so I'm going to make this a one, like a kind of more of a scripted one. So let me go ahead and put that. I'm going to put that scripted one right there and the number 5 right there. Notice that if I were to do the foiling procedure, that when I FOIL this out, I would get, for my leading coefficient, I would have, for the first, I would have 1 times x times 3x, which gives me 3x squared. That's what I want. That's what I want to get. Likewise, when I do my lasts, I would do 1 times 5, and that gives me a 5 up to, but not necessarily the correct sign. And we'll worry about the sign in just a second. But the hard part is, do I get the correct middle terms? When I do my outers and inners, combine them together, do I get the correct terms? So notice what happens when you do your outers. You would do 1 times 5 here, this 1 times this 5, and you would do this 1 times this 3. So 1 times 3. Remember, to help you keep track of which one I'm talking about, I'm doing this symbol. This 1 times this 3. So that's what you would do when you FOIL this out. And we know that we factored correctly if we get the correct middle term. Well, what's 1 times 5? That's 5. What's 1 times 3? Well, that's 3. If I combine those together, and by the way, this could be plus or minus for combining them together. If I combine these together, can I get the number 14? Well, let's check. 1 times 5 is 5. 1 times 3 is 3. Those add or subtract, if I add or subtract them together, I'll either get 8 or I'll get 2, neither of which gives me 14. So even though in this procedure, this test, I got the correct first term and I got the correct last term, I did not get the correct middle term by combining those outer and inner terms. And so that combination was wrong. Now, usually we don't write out our entire guess, because all that matters is that we get the middle terms correct. So what we're going to do here is, usually what we'll do is, when I want to check this ordered pair combination, I'm going to take 1 times 5. So there I do this 1 times this 5. And then I'm going to say, let's combine that with 3 times 1. Okay. Then the other thing I haven't mentioned yet is, notice, let's go ahead and deal with the sign now. Notice that when I multiply my lasts together, I have to get a minus sign here. For me to get a minus sign here, that means that the sign on this term and the sign on this term have to be different. How come? Because if both of these were plus signs, then when I multiply my lasts together, I'm going to get a positive number. Likewise, if both of these were minus signs, then when I multiply them together, I'm going to get a positive number. So I need these two signs to be different. So what I'm checking here is, can I take, and when I multiply 1 and 5 and 3 times 1, I'm asking, do these subtract to get 14? We'll worry about exactly getting those signs right in just a minute. And by the way, folks, for those of you that have learned other techniques for factoring, usually it's this part that I'm describing kind of in the air here as we're talking through this do these subtract and check the signs and work with that. Those are parts that teachers don't usually want to explain because it takes a long time to get a whole class on board. And so they give you more simplified methods. I think that you're ready for the kind of this more correct method for factoring. So I'm asking the question, when I take 1 times 5 and 3 times 1, do those subtract to get 14? And the answer is no. 5 and 3, there's no way I could subtract one term from the other to get the number 14. Okay? So in this case, what we were doing was we were taking the number 1 times 5 and the number 3 times 1. But we could also check the opposite combination. So I'm going to take that same 1, this leading coefficient 1, and I'm going to multiply it to this factor 5, or excuse me, to this factor 1 right here. That's scripted 1. And I'm going to then take the other leading coefficient in that pair, 3, and I'm going to multiply it to the other trailing coefficient in that pair, times 5. Okay. Notice, folks, that what we're doing here is we're checking to make sure we get the middle terms correct. So I'm doing the outers and inners process. That's why I'm saying 1 times this 1 and 3 times this 5. That's the outer and inner process of expanding. Okay, so now I'll ask the question, do these subtract to get 14? And as a reminder, we're asking do these subtract in both these cases because this sign was negative. We're checking to see if these subtract because that sign was negative. We'll deal with another case in the next problem. And here the answer is yes. If I do 1 times 1 and 3 times 5, it's possible to subtract one from the other to get the correct middle term, 14. Okay, so now that we've found these are the pairs that we want, this is the pairing that we want, we're now going to take those answers and put them up in here. So we said that we wanted to take this 1, and that was for the leading coefficient, so that's a 1x. We wanted to take, oops, let me not do that script on there because that would be incorrect. We want to do that 1x, and we said we want to multiply our 1x to the script 1 over here. So when I do my outers and inners, I want to multiply this 1x to this number 1 right here. Likewise, we said that we wanted to take 3 times 5. 3 was the opposite pair of that leading coefficient, so that's where I'm going to get that 3 from. And so what did I want to do? When I do my inners now, I want to do 3x times this number, and I want it to be 15. So we're going to do 3x times 5. So notice now, when I do my firsts, I definitely get 3x squared. When I do my lasts, I get the number 5. We'll fix the sign in just a second. And then I have ensured by checking this that my outer and inner terms work correctly. So now let's do the sign. We previously said that because this sign is negative, I know that either this sign, don't write this down just yet, folks, because I don't know if it's right, that this sign is going to be positive and this sign is going to be negative, or this sign is going to be negative and this sign will be positive, but they must be opposite signed so that when I do my lasts, I get a -5. Okay, so now the very last part of this is in the instance where these have different signs, we ask ourselves, okay, what product is larger, 1x times 1 or 3x times 5? So what's bigger, 1x times 1 or 3x times 5? And the bigger product is 3x times 5, that 15x, that's larger than the 1x. And so the bigger product, which is this pair, has to match this sign right here. So to ensure that, I'm going to make this sign minus and this sign plus. Okay? So let's check our work now, folks. If we were to FOIL this out, we would get 3x squared. We knew we would get the correct first term as soon as we picked my factor pairs this way. Likewise, when we do our lasts, we'll get -5. We knew we would get -5 once we picked any of these pairs. That would work. The key here is, do we get the correct middle terms? Well, let's check. When we do 1x times 1, we get 1x. And when we do -5 times 3x, we get -15x. Combining those two together does indeed give us the -14x that we were after, and so -14x that we were after, and so this does indeed check. Okay? So let me go ahead and put that down. I'm going to go ahead and erase that there. Hopefully you see this process. One thing you should always do when you factor is, once you've got what you think is your correct factorization, you should FOIL it out, because foiling is easy. Relative to factoring, foiling is easy, and confirm that yes, indeed, that gives us that original expression. Okay, let's go ahead and give this another shot. Let's look at this problem right here. So now we've got 3x squared plus 16x plus 5. So again, we're going to treat this like it's its own brand new problem, even though we already had some of the information here. So for these problems, what we do is we list out our factored pairs of the leading coefficient and our factored pairs of the trailing coefficient. Okay? In harder problems, you will have more pairs that you have to check. Okay? Then, what do? We're simply going to take, and let me make that again as script 1 so we can tell the difference between them. I'm going to take 1 from each of these pairs and multiply it to 1 from each of these pairs. And then I'm going to do the same with their partner values. So let's go ahead and do 1 times 5. So 1 times 5. And then we're going to check also 3 times that script 1. And we're checking to see if we get the correct middle term. Now, in this case, this is a plus sign here, so we're going to check, let me do that in a different color. We're going to check to see if they add. This is positive, so we're going to check to see if they add. So I'm going to ask the question, do these add? to our middle term here, which is 16, the middle coefficient, which is 16. Well, 1 times 5 is 5. 3 times 1 is 1. So 5, 3, can I add those together to get 16? And the answer is no. So we chose the wrong combination. Let's now check each with its opposite. So first we did 1 and 5. So now we'll do 1 and script 1. And then previously we had 3 and script 1, so now we'll do 3 and 5. So 3 and 5. And again, the key here is we're checking to see if these add. Do these add to 16? And in this case, the answer is yes. So now I'm ready to give the solution. So we had originally 3x squared plus 16x plus 5. And we knew this was going to look like something x blank something, got any room here, times something x plus or minus something. And we've now determined that what's going in these blanks are these groupings right here. And again, folks, I need you to practice this method. In longer problems, you might have many of these pairs. Okay. So we said that we wanted to take the 1 and multiply it when we do my outers and inners. When I do my outers, I want to multiply it to this script 1 right here. And we said that we wanted to do the 3, which would be right there, because that's how I get my 3x squared. And we multiplied the 3x times the number 5. So opposite the 3x. Or in another way, in the only blank remaining, I'm going to put the 5. At this point, I've done this correctly, and I've got all of these coefficients in their correct spot. I just need to assign the signs. Now, we just said that the trailing coefficient has a plus sign. That means we're either going to be multiplying a positive 5 to a positive 1. That would give me plus 5. Or we would be doing a minus 5 times a minus 1. And that would also give me plus 5. So either both middle terms are both positive, or both middle terms are both negative. So when we have the case where this trailing coefficient is positive, both these signs need to be either both positive or both minus. Finally, when we look at what we want for our middle term, we want that middle term to be a positive 16, so we're going to make both of these signs positive. Now what you should do is you should check this. Folks, sometimes people don't believe me about checking your work on these. It is possible for you to have done this whole method correct and to not get the right answer if you're dealing with a trinomial that does not factor. So you do have to check your answer. Even the best math student must check their answer when they do these problems. So actually FOIL this out. By the way, if you're always FOILing it out, you will get a better understanding for how this process works. So again, if we FOIL it out, I guess I'll do it with you here. If we do, not script, if we do 1x times 3x for my firsts, and then we do plus 1x times 1 for my outers, and then I do plus 5 times 3x for my inners, and then I do plus 5 times 1 for my last, confirm that this gives us 3x squared plus x plus 15x plus 5. And that does indeed, when you finish simplifying that, give us 3x squared plus 16x plus 5, which is what we hoped it would do. All right. So folks, my recommendation at this point is to pause the video and try both these problems. So please pause the video, give them a shot, and I will work through them with you in just a moment. Okay, so hopefully you actually tried this, folks, because if you're not trying these problems, you're not going to realize what's hard, what's easy, what's difficult about them. So let's go ahead and work through this. We're going to treat it like it's its own brand new problem. So I'm going to list out my leading coefficient, 3, my trailing coefficient, 5, and I'm going to list out their factor pairs, 1 and 3, script 1, and 5. Okay. Then because this trailing coefficient is, again, negative, we're going to be asking, do they subtract? Okay. So let's check this. we're going to take these different factored pairs. Let's do 1, and let's do script 1, and then we'll do 3 and then 5. And we're asking, do these, in this case, subtract, because this trailing coefficient is negative, to get positive 14. That's what we're checking. Well, let's see here. If we do 1 times 1 and 3 times 5, well, 1 times 1 is 1, and 3 times 5, that's 15. Yes, we hit our target on the first try. Now, students don't like to learn this method. It's a little bit harder. I can't really give you a set of defined steps for how to do this, so it's definitely a more challenging method. But eventually, this method will be faster, and especially this method of checking. Rather than systematically checking them all, your mind will sort of gravitate to the right combinations. So it is really worth learning this method. Okay, so now that we found our correct order pairing, we got there on the first try, we're going to go ahead and set this up so we know we've got 3x squared plus 14x minus 5, and we're going to go ahead and fill in the binomials. So we knew that this was going to be something and something and something and something, where this was x and this is x, and we decided, okay, we're going to use the pair 1 and 3 because it was the only option, but we still had to get the correct alignment. But we had this 1x and this 3x, and then we said that we wanted to multiply the leading coefficient 1, to the number 1 when we do our outers. And so let's go ahead and put this 1 right here, and we wanted to multiply the 3 to the 5. So there's the 3 and there is the 5. That was the correct combination that we were looking for. Now we just have to decide the signs. Okay, well, we knew that we were after both signs being opposite because this is subtraction. So this is either going to be, don't write this down just yet, this is either going to be a plus and a minus or a minus and a plus. It's going to be one of those combinations. And remember what we check here, when this is subtraction, we check to see whether the larger product matches the sign of the inner term. So what's larger, 1x times 1 or 5 times 3x? Well, 5 times 3x is larger than 1x times 1, so it's with this combination that I want to make sure that we get the correct inner term. So I'm going to make this sign right here a plus sign, and then this sign, because it has to be opposite and for various other reasons, is going to be negative. Okay? You should then check this. I won't do it this time. I checked the last one. I'll let you check this, FOIL it out. By the way, somebody might ask, could you rewrite this as just x plus 5? Times 3x minus 1, certainly. You don't need to have the 1 there, although that 1 was integral to our coming up with the correct combination. Okay? So just go ahead and giving you the final solution for this one. Let's go ahead and just say when we go to do 3x squared minus 16x plus 5, you should have found, and you should be working through this method to check this, you should have found that we ended up with 3x and x, that gives us the 3x squared, and then we would have 5 and 1, and then both these signs would be minus here, and you can check. That gives us 3x squared, correct. That gives us a plus 5 for the last, correct, and the inners would give us the correct minus 16. So we've got that answer correct. Okay, so I'm going to leave you to try these problems in just a minute. What I'd like to do is let's go ahead and flip to the next page, and I just want to make this one last comment for you. Sometimes polynomials do not factor nicely. And what we mean by that is, I'll explain down below here, but usually when that's the case, we say that the polynomial does not factor. So let's check that. This looks very similar to the examples we were just working. So our leading coefficient is 3 and our trailing coefficient is 5, and the factored pairs are 1 times 3 and 1 times 5. And when I go to check these, let's see here, we would do, let me make that a script 1 again, and we would do, say, 1 times script 1, and we're going to combine that with 3 and 5. And since the trailing coefficient here is positive, we want to check to see whether we can add the outer and inner terms together to give the correct term. And so if I do 1 times 1 and add that, combine that through addition with 3 times 5, is that going to get me to 10? And the answer is no. But we also have the other combination to check. So we could do this one not times script 1, but times 5, so 1 times 5, and then this 3, not times 5, but times script 1, so 3 times script 1. And is it possible to add these together to get 10? And in this case, nothing works. So in our class, what we're going to say is that this does not factor. Okay? That's a fine way to answer the question. Technically, I'll just say this, technically what we mean is that this does not factor in the integers, meaning I can't write it out in a nice factored form. It actually does factor. I can write it factored, but I'll need to introduce square roots into the problem. So if you're interested in what exactly do we mean by factoring, I'll leave you to read this collection of notes here, which I think is actually pretty interesting. So maybe read through it, but please, if you feel overwhelmed by what's being stated here, don't worry, it's not quite what we're doing in this course, but it does explain why sometimes we say things don't factor when really they do. That just means they don't factor nicely. Okay, that wraps us up. What I want you to do is I want you to go ahead and try number 4 on your own. So for these two problems, you're going to go ahead, I'll get this one started for you. You're going to have a leading coefficient of 2 and a trailing coefficient of 7, and you'll have 1 times 2, and you'll have 1 times 7, and then I want you to go ahead and start factoring this using this method that we've discussed. You may have a method that you like better for factoring, and after today, or after our factoring review, you're welcome to use that method, but I want you to try this method that I'm teaching you because I promise you that it is eventually a better method for factoring. All right, folks, thanks for your patience, and I will see you next time.